Good morning, students. So we are in the session 11 of the work energy power. So we are discussing what? Currently we are in the applications of the work energy theorem for this vertical circular motion concept. Okay. So already we have talked about the particle going in vertical circle, the velocity relations. Okay, already. And we also looked at what will be the tension velocity relation. So velocity relations in Sonna, what is it? How the velocity at a point is related to the initial velocity. Initial velocity means what? We take the bottommost point to be the initial velocity. Okay. Adukapram we have looked at what is the relation between the tension. Because here we are taking the example of stone that is tied to a rope or object tied to a rope. So the tension force will be the force that will try to create the centripetal acceleration. Tension force mattum kediyadu, there will be also sometimes the effect of gravity. Okay, but we have seen how the tension will be changing depending upon the velocity at that point. Okay, wow. So again we have talked about the tension velocity or relation at the bottommost point. Adukapram point 1 we'll generally take it as what? When the rope becomes horizontal. And the madri we talked about the relation when the object is at the topmost point. Adukapram we have even talked about the general position la what is the relation between the tension and the velocity. Okay, so in Canada we will start with what are the conditions for the vertical circular motion. Vertical circular motion and so it is not like always the object is going to always go in the full circle. Okay, so generally நம்ம observe பண்ணா எப்படி நடக்கும்? Say for example we are having a stone tied to a rope னு வெச்சுக்கோங்க. ஓகேவா? So இங்க ஒரு object இருக்கா tied to that rope. Okay, so நீங்க கொஞ்சம் small velocity கொடுத்தா என்ன ஆகும்? அப்படியே it will go for some distance in that vertical circle, போயிட்டு it will not be able to go any further. அதுக்கப்புறம் it will start performing what? Oscillations. இது ஒரு common observation. So for small velocities, right, என்ன நடக்கும்? There will be oscillations. இது எப்படி தெரியுமா? So why is it coming back? ஏன்னா இங்க ரீச் பண்ணதுக்கு அப்புறம் the velocity is becoming zero. அதனால தானா அதே கண்டினியூ பண்ண முடியலன்னா because the velocity is becoming what? Zero. So for small velocity that we give for that object என்ன நடக்கும்? There will be oscillations. இதுக்கு boundary எங்க தெரியுமா? So what is the boundary for the oscillations? When the object is able to go to that the horizontal most point inga varakum. So if it is able to go to that horizontal point, right, up to that we will still have what? Oscillations. Okay va? So if your initial velocity is not able to make the object to reach this point 1 or position 1 or horizontal position, appo enna agum? There will be oscillations. Appo கொஞ்சம் distance move ஆயிட்டு it will keep performing the oscillations. Okay va? So this is the concept of oscillations. ரெண்டாவது என்னன்னா இங்க கொஞ்சம் நீங்க velocity கொடுத்தா or you give some more higher value of velocity, அப்ப என்ன தெரியுமா? practically நம்ம observe பண்ணி பார்க்கலாம். So it will be able to cross this horizontal position. Okay, அது cross பண்ணதுக்கு அப்புறம் தான் you will be having the other side in a lower half of the circle னு சொல்லலாம், அடுத்தது upper half of the circle. அப்ப என்ன தெரியுமா? Sometimes after going to some height above this horizontal level னு சொன்னா what is it? That point 1 அதுக்கு மேல கொஞ்சம் distance move பண்ணதுக்கு அப்புறம் you will see that the stone or that object can sometimes come out of the circular path. ஏன் தெரியுமா? Why it comes out of circular path? நீங்க observe பண்ணல, like you just give some more velocity means it will cross the horizontal point. Cross பண்ணதுக்கு அப்புறம் it will go to some height and again it will just come out of the circle. ஏன் அப்படி வருதுன்னா because when something will come out of circular path, because when you look at the stone it is tied to the rope. If the rope is loosening or rope is slacking னு வெச்சுக்கோங்க, அப்ப என்ன ஆகும்? The distance between the center of the circle and the rope cannot be maintain the same. So adanal it will come out of the circular path. So for the particle to come out of circular path, the rope has to become what? Loosen. Okay va? When it is able to generally cross the horizontal point and not able to reach the topmost point. When it is not able to reach the topmost point, typically it will go to some height above the horizontal, it will come out of the circular. Typically it will once and the circle and the value it will go in a parabolic type of a path. That's what we discuss panala, but that is the situation. Irregular observe panna, it will look like irregular. The parabolic madri poite killa vara madri irukku. Okay va? But if you are giving a sufficiently high velocity, so sufficiently high velocity kuduta, what you will see, the particle will be able to go in the full circle or complete circle. That is what we call as looping and solala. Looping and it is able to go in the complete circles. Okay va? So in the madri moonu situations varum. First you can have my initial point lo konja velocity kudutha, it will be what? Sufficient only to create the oscillations. Full circular motion varadu. It will be only giving us what? Oscillations. Okay va? So adukara oru boundary enga till the object is able to reach that horizontal position. That's the boundary, oscillations are a boundary. Okay. After that, velocity, what is going to happen? It is going to go above the horizontal position, but it will come out of the circular path because the rope will become slackening or loosened. Okay. Third situation, and if you are giving sufficiently high velocity, means it will be able to complete these full loops. Okay. So either complete vertical circular motion. Okay. So we are going to look at the conditions for each of them. Okay. So first in the oscillations or the condition part. So already what is it? The particle should not be able to reach this horizontal position. The particle should not be able to reach this horizontal position. Okay. So if the velocity is u and h, the velocity here is what? U, initial velocity. Okay. The velocity, that is what we call as generally v1, right? What is the relation? U square is equal to v1 square plus 2gr. Already in the relation delay. What is it? U square is equal to what? v1 square plus 2gr. Okay. So oscillations will be happening till it is reaching this particular point. Oscillations is happening till it is reaching this particular point. Okay. So we will have to look at if it is reaching this horizontal position. Adukana or minimum possible case enna? What is the minimum possible scenario? When it is reaching, when the object is reaching that horizontal point 1, its velocity should become 0. So what is the minimum possible way of reaching that horizontal position? We give that much velocity where the object is able to just reach that horizontal point. Just reach and sonna, and the object velocity will become 0 when it is reaching the horizontal point. Okay. Now in the equation v1 is equal to 0 substitute panna varum. U square is equal to 2gr varum. Adalanda u is equal to what? Root 2gr. We are going to talk about the condition for the oscillations. What is the velocity you should give at the bottommost point, so that when the object reaches this point 1, the velocity is becoming 0. If you give a velocity at the bottommost point u, which is less than or equal to root 2gr. Root 2gr exact it will be able to just reach this horizontal point. Okay va? If the velocity that you are giving at the bottommost point, so bottommost point and sometimes we will also say initial point. And our understanding will be start vertical circular motion. Okay va? So if the velocity you are giving at the bottommost point is less than root 2gr, the particle will not be able to reach this horizontal position. It will be reaching to some point. It will reach to some point here, and then you will see what? Oscillations. Okay va? So what is the condition for the oscillations? The conditions and so now we are looking at what? Conditions for the initial velocity. So initial velocity value that's the condition. Okay va? So what is the condition we are getting? The velocity at the bottommost point, right, should be less than or equal to root 2gr. then if it is exactly root 2g or right, it will be able to just reach that and the horizontal point. Adhu kami irundha, it will be able to reach to some point somewhere in between. So this is our oscillation situation. Inga enna nadakum, oscillations nadakum. Okay va? So this is the condition for the oscillations. Over. Paranga, we have a question. Already நம்ம ஆன்சர் மார்க் பண்ணி வச்சிருக்கோம், பட் look at this. A simple pendulum with a bob mass m and length x is held in position at an angle theta 1 and then at angle theta 2 with the vertical. So ஒரு கேஸ்ல என்ன, we are holding it at an angle theta 1. இங்க பாருங்க, so இப்படி இருக்கா. So இங்க நம்ம ஹோல்ட் பண்ணிருக்கோம் theta 1. ஓகேவா? அடுத்த கேஸ்ல என்ன, we are holding it with an angle theta 2. When released from these positions, speeds with which it passes the lowest position are v1 and v2. Lowest position and சொன்னா what is it? This is the lowest position, right? இங்கல இருந்து நம்ம ரிலீஸ் பண்ணா lowest position means what? The bottommost point. அதுக்கு என்னன்னா, in oscillation chapter we also call it as equilibrium position னு சொல்லுவோம். ஓகேவா? So if the angle at which you are releasing is theta 1, the velocity at the bottommost or lowest point is what? v1. If the angle at which you are leaving is theta 2, the velocity at the bottommost point எவ்வளவு? v2. அதோட ரேஷியோ கேக்குறாங்க. what they are asking, the ratio of v1 by v2. இங்க பாருங்க, இப்போ நம்ம இங்கல இருந்து ரிலீஸ் பண்ணா what is the kinetic energy initially? 0 தானா? ஏன்னா லீசிங் னு சொன்னா kinetic energy 0. potential energy எவ்வளவு? ஆல்ரெடி நம்ம இந்த டிஸ்கஷன் பண்ணிருக்கோம். like if the radius is x னு வெச்சுக்கோங்க, இங்க என்ன, the length of the pendulum எவ்வளவு? x. so the radius will be x. okay, so the theta 1 position la what is the height above the reference level? ஞாபகம் இருக்கா? what is the formula we have derived? h is equal to r into 1 minus cos theta. நீங்க ஒரு theta positionல ஹோல்ட் பண்ணா what is the height of that object above the reference level? r into 1 minus cos theta தானா? so இங்க பாருங்க, what is it going to be? r க்கு பதிலா என்ன வரும்? x. x into 1 minus cos theta 1 வரும். அதுதான் height. so potential energy எவ்வளவு? mg into h, which is mgx into 1 minus cos theta 1. அதுதான் potential energy initial point ல. இங்க final point ன்னு சொன்னா what is it? the lowest point. ஓகேவா? so இங்க பாருங்க, அதுதான ரெஃபரன்ஸ். so இங்க potential energy எவ்வளவு? 0. வெறும் kinetic energy மட்டும் தான் இருக்கும். what is the kinetic energy? half m v1 square. ஏன்னா velocity we are taking it as what? v1. இப்போ பாருங்க, initial kinetic energy plus potential energy ஓட வேல்யூ mgx into 1 minus cos theta 1 is equal to final state ல இருக்கிற kinetic energy ஓட வேல்யூ plus potential energy வேல்யூ half m into the v1 square. இங்க என்னது? m cancel ஆயிடும். cancel பண்ணா 2 இந்த பக்கம் எடுத்துட்டு வந்தா it will go to the numerator தானா? so 2gx into 1 minus cos theta 1 is equal to v1 square. அதுக்கப்புறம் v1 எவ்வளவு? ரெண்டு பக்கம் நம்ம ரூட் எடுக்கணும். அதுல இருந்து what is the v1 value going to be? we should take a square root on both sides. அப்படிதானா? square root எடுத்தா என்ன வரும்? v1 ஓட value will be equal to what? root 2gx into 1 minus cos theta 1. அதுதான் v1 ஓட value. ஓகேவா? so இப்போ என்ன தெரியுமா? when we change the position to theta 2, அங்க வெறும் அந்த ஆங்கிள் மட்டும் தானே சேஞ்ச் ஆகும், மத்ததெல்லாம் it will be the same because same pendulum எல்லாம் everything is same, right? வெறும் அந்த ஆங்கிள் வேல்யூ மட்டும் சேஞ்ச் ஆகும். so அதனால we will get, நீங்க சால்வ் பண்ணா இதுதான் வரும். இங்க இருந்து டைரக்டா நம்ம அந்த வேல்யூ எக்ஸ்பிரஷன் நம்ம எழுதலாம். எப்படி பாருங்க, என்ன சேஞ்ச் ஆகும்? வெறும் அந்த theta மட்டும். so the velocity in the case of releasing the object from that angle theta 2, அதோட எக்ஸ்பிரஷன் எப்படி வரும் பாருங்க? சேம். ஏன்னா மத்ததெல்லாம் சேம், ரைட்? root 2gx into 1 minus cos theta 2 வரும். அதுல அவ்வளவுதான் டிஃபரன்ஸ். ஓகேவா? வேணும்னா நீங்க செக் பண்ணி பார்க்கலாம். இங்க டிஃபரன்ஸ் என்ன வருது? வெறும் அந்த ஆங்கிள் பட்டு பொசிஷன்ல மட்டும் தான். மத்ததெல்லாம் சேம். சேம் பெண்டுலம், சேம் பாப், எவ்ரிதிங் இஸ் சேம். இப்போ பாருங்க, what is the ratio of the v1 by v2? அதுதானா? ratio of the v1 by v2 means root 2gx into 1 minus cos theta 1 divide by root 2gx into 1 minus cos theta 2. இங்க பாருங்க 2gx cancel ஆயிடும், root நம்ம cancel பண்ணக்கூடாது. So that is some mistake that some people will do. அதை நீங்க கண்டிப்பா ஞாபகம் வச்சுக்கோங்க. We should not do such kind of simple mistakes. ஓகேவா? So இப்போ என்ன finally root of 1 minus cos theta 1 divided by 1 minus cos theta 2. Then what is the answer for this? Option 2. Check பண்ணுங்க, we should get the same answer. What is the answer? Option 2 வரணும். ஓகே, ஸோ அடுத்த கண்டிஷன் போகலாம். அடுத்த கண்டிஷன் என்ன? ஸ்லாக்கிங் வர்சஸ் லூப்பிங். ஸோ ஏன் நம்ம வர்சஸ் லூப்பிங்னு போட்டிருக்கோம்னா, பிகாஸ் அந்த ஸ்லாக்கிங் வரலன்னா இட் வில் பி ஏபிள் டு கோ த்ரூ த ஃபுல் சர்க்கிள், ரைட்? ஓகே, ஸோ இப்போ பாருங்க, we are giving a velocity at the bottommost point. ஓகேவா? ஸோ அதோட வேல்யூ நம்ம u1 எக்ஸ்பிரஸ் பண்ணியிருக்கோம். ஸோ அங்கேருந்து if you are giving it velocity which is more than root 2gr, ஏன்னா நம்ம root 2gr or less than root 2gr means what is it? Oscillation ஓட condition. அதுக்கு மேல நம்ம கொடுத்ததா we will be able to have what? The object getting into the other side. Other side means the upper half of the vertical circle. அந்த பக்கம் போயிடும். ஓகேவா? ஸோ எங்க தெரியுமா, as it is going up the tension values will keep எப்படி decreasing, because in the vertical circular motion as the object is going up tension will keep decreasing. எங்க minimum இருக்கும் tension is going to be minimum at the topmost point. So எங்க tension ஓட value will be minimum in the vertical circular motion, it will be minimum at the topmost point. இங்க என்ன தெரியுமா, what is the condition for the slacking? கண்டிப்பா ஒரு லிமிட் இருக்கு நம்ம கிட்ட, என்னது? the u value should be more than root 2gr. ஏன்னா இந்த root 2gr க்கு மேல இருந்ததா it will go to the upper half. அப்போதான் அந்த ஸ்லாக்கிங் பத்தி நம்ம பேச முடியும். இல்லைன்னா we'll be having what? Oscillations. ஓகேவா? so if you are able to make this object cross this horizontal point, cross பண்ணிட்டு போனா it will be able to go to that other side and it will be able to complete the vertical circle if you are able to meet the looping condition. இல்லைன்னா நடுவில் at some point it will be slacking. இங்க பாருங்க, what is the condition for the slacking? Tension at that point, அந்த particular location la tension should become what? 0. அப்ப என்ன ஆகும்? அப்படியே அந்த circular motion வந்து வெளியே வரும். So we will look at the condition for the looping. Okay, so looping and so what is it? Once it crosses the horizontal point tension should never become 0. அதுதானா? the horizontal point cross பண்ணதுக்கு அப்புறம் tension should never become 0. tension should never become 0 means what? என்ன சொல்லலாம், it should be always more than or equal to 0. tension ஓட value should be always more than or equal to 0. அதுதானா? so இப்போ என்ன தெரியுமா, at each and every point if you consider tension ஓட value will be always more than the topmost point. ஏன்னா நம்ம மேல போகும்போது tension ஓட value will keep decreasing, right? so நம்ம நடுவில் எங்கேயாவது எடுக்கலாம், t dash ன்னு சொல்லலாம், t double dash, t triple dash அந்த மாதிரி. all these values are going to be more than the tension at the topmost point. அங்கதான் minimum. so இப்போ looping condition என்ன தெரியுமா, we will take that tension at the topmost point. okay, அதுக்கு ஆல்ரெடி நம்ம t2 அதுதான வேல்யூ. ஏன்னா t1 ன்னு சொன்னா we are taking the horizontal position, t2 ன்னா topmost point. t2 ஓட வேல்யூ இங்க பாருங்க if you say that T2 ஓட value should be more than or equal to 0 அப்படி நம்ம சொன்னா ஏன்னா அதுக்கு கீழ இருக்கிற பாயிண்ட்ஸ்ல என்னது tension value is always more than the T2. So அதனால if you say that T2 is more than or equal to 0, all the other points also tension will be what? More than or equal to 0, which means what? We are putting a condition on the tension at the topmost point. Topmost point la tension 0 ஆகலன்னா கீழ எங்கேயும் it will not become 0, which means what? We will be able to have looping. We will be able to have ஏன்னா what is the condition for the slacking? நடுல எங்கயாவது tension 0 ஆயிடுச்சு வெச்சுக்கோங்க, that is the slacking. அது ஆக கூடாதுன்னா what is the situation? We are saying tension nowhere should become 0. அதுக்கு என்ன what is the situation we are taking? ஏன்னா tension at the topmost point is the least, right? So if we say the tension at the topmost point should be more than or equal to 0 means each and every other point also tension will be what? More than 0. Okay va? So paranga, we are going to apply the condition on the tension at the topmost point. Tension at the topmost point in the formula m into v2 square by r minus mg. இதுதானா tension velocity formula. T2 value என்ன? m into v2 square by r minus mg. அதோட value should be more than or equal to 0. mg நம்ம அந்த பக்கம் எடுத்துட்டு போனா what we'll have? m into v2 square by r should be more than or equal to mg வரும். mm cancel பண்ணா v2 square would be more than or equal to rg. அதுல இருந்து v2 ஓட value should be more than or equal to root rg. Means what? இந்த topmost pointல tension should be more than or equal to 0. அப்படி நம்ம ஒரு கண்டிஷன் எடுத்தா அதுல இருந்து நமக்கு velocity ஓட இதுல ஒரு ரிசல்ட் வருது. What is it? Velocity at the topmost point should be more than or equal to what? Root rg. Velocity at the topmost point should be more than or equal to what? Root rg ன்னு சொல்லலாம், or root gr. Okay. இப்போ நமக்கு என்ன தெரியுமா? We are looking for condition in terms of initial velocity base பண்ணி. We are looking at the conditions in terms of what? Initial velocity. Okay. So பாருங்க, what is the relation we can have between u and v2? அது நமக்கிட்ட already இருக்கா. What is it? u square is equal to what? v2 square plus 4gr. அதுதானா? இதெல்லாம் ஆல்ரெடி நம்ம டெரைவ் பண்ணிருக்கோம். u square is equal to what? v2 square plus 4gr. So இங்கிருந்து பாருங்க, v2 square எவ்வளவு? அப்படியே நம்ம அந்த 4gr லெஃப்ட் சைடுல எடுத்துட்டு வந்தா u square minus 4gr is equal to v2 square. அப்படி நீங்க இந்த இதுல சால்வ் பண்ண சப்ஸ்டிட்யூட் பண்ணுங்க. So இந்த v2 square value should be more than or equal to what? Root rg or root gr, right? The v2 square க்கு பதிலா just substitute this. u square minus 4gr should be more than or equal to gr. Right side எடுத்துட்டு போங்க. u square should be more than or equal to gr plus 4gr. அது எவ்வளவு? 5gr. So u square should be more than or equal to 5gr, or u should be more than or equal to root 5gr. Okay va? So what is the condition? u oda value, right, should be more than or equal to root 5gr. அப்படி இருந்தா என்ன ஆகும்? Tension நடுவுல எங்கேயும் it will not become 0, which means the particle will be able to go through the looping or complete circle. Okay, so பாருங்க, so we will divide the conditions. என்னது பாருங்க, if your initial velocity at the bottommost point, so adu base panni da we are looking at all the conditions. Initial velocity at the bottommost point. Okay, adoda value is okay, so the initial velocity at the initial velocity at the bottommost point, right, is less than or equal to root 2gr. Angane nadakum, we will be having the oscillations. Adana, if the initial velocity is more than or equal to root 5gr, appo enna agum? Looping or complete circle. Complete circular motion varum. Okay, enna if the velocity is more than or equal to 5gr means நடுவுல எங்கேயும் tension 0 ஆகாது, which means what? The full circle is going to be ensured. அவ்வளவுதான். So what is the condition for the slacking? Slacking னு சொன்னா நடுவுல somewhere it should become what? Situation where the tension is becoming 0 and particle comes out of the circle. அதுக்கு என்ன? இங்க பாருங்க, So this is less than or equal to root 2gr. Then more than or equal to 5gr. If you are giving a velocity which is in between the two and so now what is it? The root 2gr up to root 5gr. And the madri or velocity what is it going to have? It will be giving us or incomplete vertical circular motion and or slacking is going to occur. There will be root 5gr. Okay, wow. So root 2gr up to root 5gr. And the limit velocity, initial velocity, what is going to happen? Somewhere in between and the circular motion tension 0 and it will come out of the circular path. Okay, wow. So this is what is the conditions in terms of the velocity. Okay, wow. So the correct because this can be useful sometimes. Like think in one of the past year, a straight question on the like what is the minimum velocity at the bottommost point or the lowest point to ensure complete circular motion. That value root 5gr. In the values based we can get the questions. Okay. So if we look at what is the situation about the point where the rope is slacking. And the velocity condition but so look at this. So we are starting the motion from here and we are giving a velocity which is between root 2gr to root 5gr. On the range of velocity what is going to happen on the horizontal point cross somewhere it will become what? A situation where the tension is becoming 0. So tension 0 on the particle will not be tied to the rope. It will start going in a free particle madri. Velocity will be along the tangent because the velocity will be what? Always along the tangent to circle, right? The tangential direction it will start moving like a free particle. So overall it will be having a path which will be parabolic. The path discuss so if you are, it is like what? With respect to horizontal, horizontal angle project so that's a parabolic path. That's a vertical 2D motion. If you are projecting a particle making an angle it will follow what? Parabolic path. Okay. But sometimes we can have questions relating to the point where it is going to slack. And sometimes we will be having questions related to the point where it will be slacking. Typically they will be asking us what is the height of the point where it is going to slack from the reference level. So reference level, what is the height where it is going to slack? And they can even ask us what is the velocity. Point of slacking, what is the velocity? But and the point of slacking there the tension should become 0. All of the point of slacking the tension at that point should become 0. And the condition use we will be able to solve the information. Okay. But mathematics we are going to use the same and the conservation of mechanical energy principle use okay. So point of slacking the tension becomes 0 and particle starts going in a parabolic path. Okay, va? So conditions. So overall in the condition in a neat level we may not get many questions. And the slacking what up in some other examinations, right? They will give us questions mostly on and the point of slacking or the velocity at the point of slacking and the other questions varla. But we should look at mostly on the conditions. What are the things? I am writing again. U less than or equal to root 2gr means what? Oscillations. Okay. Root 2gr up to root 5gr. It will become what? Situation where the tension is becoming 0 and there will be slacking. Slacking on solid or the rope is becoming loose. U more than or equal to root 5gr means what? Then the complete circular motion on solid or we can say looping on solid. Okay, va? So in the conditions questions paranga. So in the madri like sometimes we can get straight questions. A pendulum consists of a bob mass m suspended by a light inextensible string length L at the point O. So point O we are hanging it. What is the horizontal velocity V, the bottommost point, to be given to the bob at the position A so that it passes the point B and does not reach the point C. என்னது அந்த B cross பண்ணணும் பாருங்க. This is what we are saying as the slacking condition, right? என்னது என்ன கேக்குறாங்க question statementல பாருங்க, so that it passes the point B. அதாவது that is the horizontal point, right? இது cross பண்ணணும் and it does not reach the point C. இது reach ஆகக்கூடாது means நடுவில் எங்கேயாவது ஒரு இடத்துல it will become what situation where the tension is becoming zero. அங்கலேருந்து அப்படியே ஒரு parabolic pathல போயிடும். So what is it? What is the initial velocity oda condition for the slacking? என்னது root 2g r எவ்வளோ l தானா length of the rope root 2gl இருந்து up to root 5gl அதுதானா என்ன சொல்லிருக்கோம் root 2gr ன்னு சொல்லிருக்கோம். What is the r? R is the radius of the circular path. Okay va? So inga the length of the rope is the radius, right? So root 2gl இருந்து if the velocity we are giving at the bottommost point is up to root 5gl வச்சுக்கோங்க, then it will be a what? The condition for the slacking. The point B cross ஆகும். Slacking எப்போ வரும்? It should cross the horizontal point. அந்த point நம்ம cross பண்ணலன்னா what is it? Oh, we are giving a velocity which is less than or equal to root 2gl. அப்ப என்ன நடக்கும்? The point B reach ஆகாது. Somewhere in between it will reach a stage where the velocity is zero. அப்ப என்ன நடக்கும்? Oscillations. The velocity is less than or equal to root 2gl, oscillations. Root 2gl இருந்து up to root 5gl. அதானது நடுவில் somewhere in between we will reach the slacking point. If the initial velocity given is more than or equal to root 5gl, then what is going to happen? Complete circular motion or looping will happen. Okay va? So அடுத்த question பாருங்க. A bob attached with a light string of radius r is given an initial velocity root 7gr at the bottommost point. So என்னது பாருங்க bottommost point we are giving velocity எவ்வளவு root 7gr நம்ம கொடுத்திருக்கோம் root 7gr கொடுத்திருக்கோம். What they are asking, what is the velocity at the topmost point? Topmost point ன்னு சொன்னா v2. Straight நம்ம கிட்ட ஃபார்முலா இருக்கு. What is it? Relation என்ன? u square is equal to v2 square plus 4gr. அதுதானா? அப்படியே நாங்க இந்த 4gr left side எடுத்துட்டு போங்க. u square minus 4gr is equal to v2 square. u square எவ்வளவு? u என்னது root 7gr means u square will be 7gr minus 4gr means 3gr. v2 square எவ்வளவு 3gr. So v2 is equal to what? root 3gr. அவ்வளவுதான். So v2 ஓட வேல்யூ என்ன? root 3gr. Topmost point la what will be the velocity? Straight. See, நமக்கு என்னென்ன வேணுங்க? velocity relations, particularly the bottommost point, அப்புறம் horizontal position, அப்புறம் topmost point. அது ஒன்று. ரெண்டாவது the tension relations. அதுலேயே நம்ம general position பற்றி அந்த அளவுக்கு நம்ம focus பண்ண தேவையில்லை. We have to mostly look at what the tension relations at the bottommost point, அப்புறம் horizontal position, அப்புறம் topmost point. அதுக்கப்புறம் we have to look at the conditions for the oscillations to happen, conditions for the looping, and condition for the slacking. Okay va? So பாருங்க, this question is based on the relationship in terms of the velocities. அதுக்கப்புறம் relationship. So second point என்ன? part B என்னது இதுல? They are asking us what is the tension at the topmost point. tension எவ்வளவு கேக்குறாங்க. What is the formula for that? T2 formula என்ன? T2 is equal to what? m into v2 square by r minus mg தானா? இந்த ஃபார்முலா எல்லாம் நமக்கு ஞாபகம் வச்சுக்கணும். what is the T2 ஓட வேல்யூ? tension at the topmost point எவ்வளவு? m into v2 square by r minus mg. v2 square எவ்வளவு? 3gr. ஓகேவா? r கேன்சல் ஆயிடும். இது என்னது? 3mg minus mg. அது 2mg. அதுதான் T2. So tension at the topmost point எவ்வளவு? 2mg. Alright, that's it. So we are using what? The velocity relation between the bottommost point and topmost point. அப்புறம் we are using the tension with the relation particular velocity. ஓகேவா? So அடுத்த question பாருங்க. நான் சொன்ன தெரியுமா? These are the kind of questions where they will ask about the slacking. So பாருங்க question என்ன? a particle is suspended from the fixed point by a string of length 5 meter. So fixed point length we are suspending the particle. So length 5 meters means straight on minus radius of the circular path 5 meters. It is projected from the equilibrium position. Equilibrium position na, what is it? The bottommost point. Okay, with such a velocity that the string slackens after it has reached 8 meters above the lowest point. Enga slack agum 8 meters above the lowest point. Paranga. So horizontal position kita nama vandha nichukonga. When we come to horizontal position, we have reached 5 meters above the bottommost point. Angalendu ingonnu 3 meters. Total evala. See, paranga is a reference. Horizontal position kita reach panna, it is like what we have come to a height of 5 meters above the equilibrium. And this is 5 meters, right? Our height is 8 meters above the lowest point. Appadi sonna, what is it? On the horizontal level landu we have gone up to 3 meters. Horizontal level landu we have gone up to 3 meters. Okay va? Enna kekranga paranga, find the velocity of the particle just before the string slackens. Means on the point where it is slacking, right? And that we have to find what is the velocity. And that we have to find what is the velocity. Okay va? So we have to look at the general relations between the parameters. Eppadi paranga? So inga velocity v nu vechukonga. Inga irukra velocity enna v. Okay. So adukku enna varum conditions paranga? What are the conditions we will be able to have? The velocity will be along the tangential path just before it is slacking. Appadithaan irukum. So inga paranga, weight will be down in the angle நம்ம alpha வெச்சுக்கலாம். This is 5 meters. Okay va? So weight நம்ம resolve பண்ணா பாருங்க, weight எப்படி? If you resolve the weight, இது alpha ன்னு சொன்னா this is 90 minus alpha, so இங்க alpha வரும். So weight நம்ம resolve பண்ணா mg cos alpha இப்படி போகும், mg sin alpha இந்த பக்கம் radial direction. Okay va? So இப்ப பாருங்க, அங்க இருக்கிற tension T ன்னு வெச்சுக்கோங்க. T plus mg sin alpha is equal to what? M into v square by r. Adana enna, the net force towards the center of the circle is equal to what? M into v square by r. In the tension we are equating is 0 because that is the point of slacking, right? Which means mg sin alpha value is equal to what? M into v square by r. Idhila mm நம்ம cancel பண்ணலாம். G into sin alpha எவ்வளவு பாருங்க, opposite எவ்வளவு 3, hypotenuse 5, so 3 by 5, that is sin alpha value. V square by r means what? 5. So in the 5 cancel add on. G into 3 and so now what is it? G nama 10 edukala, so which is what? 30 is equal to v square. Adilande v straight over namakku v oda value na root 30. Avladha. So enna pannirukkom, at that point where it is slacking, right? We are applying the condition for the slacking. Condition for the slacking and so now what is it? Anga tension oda value should be what? It should become what? 0 dana. So anga relation net centripetal force value paatha, what is it? T plus mg sin alpha varudhu. Okay, alpha is what? The angle we are taking above the horizontal level. Horizontal level landu we are marking an angle alpha. Appadi nama mark panna, observe panni parunga, weight oda components mg cos alpha tangential direction la poidum. Mg sin alpha will be along the radial towards the center vara madri. So T plus mg sin alpha oda mv square by r. So inga nama slacking and sonna tension oda value should be equal to 0. Adana. So 0 equate panna, we will get mg sin alpha is equal to mv square by r. V is the velocity at the point. Adalinde sin alpha nama substitute panna, sin alpha oda value na 3 by 5. Substitute panna, we are getting straight away v. V evla root 30. Okay va? So in the madri questions varala regarding the slacking. Other than we look at the particle which is in a vertical circle but inside a smooth spherical shell. Or smooth spherical shell kulla. Like ingane theriyuma, as it is same da, matadella same, but difference enna, angane when you are looking at a point or an object connected to the rope, angane varum tension. Tension is the one that is trying to, gravitation or component, the weight component varum, but tension is the one that is trying to generally create the centripetal acceleration. Ingane theriyuma, the same role is going to be played by the normal reaction. பாருங்க இங்க we are having a particle, so இங்கல இந்த bottom most point ல வந்து நீங்க ஒரு velocity கொடுத்து வெச்சுக்கோங்க. What is going to happen? The particle is going to go in the vertical circle, but inside this smooth spherical shell. The spherical shell உள்ள இருக்கா, it is inside the spherical shell. இங்கேயும் அங்க we are going to get the same result, but difference என்ன தெரியுமா? அங்க என்னது, when you are looking at an object tied to the rope, அங்க tension act ஆகும். அதுக்கு பதிலா இங்க என்ன வரும், நார்மல் ரியாக்ஷன் வரும். ஓகேவா? சோ டென்ஷனுக்கு பதிலா என்ன வரும், நார்மல் ரியாக்ஷன் வரும். பாருங்க, சோ இந்த கண்டிஷன் ஆல்மோஸ்ட் சேம் தான். சோ கண்டிஷன் ஃபார் தி லூப்பிங் என்ன, u ஓட வேல்யூ should be more than or equal to root 5 gr. u ஓட வேல்யூ should be more than or equal to root 5 gr. ஓகே, இப்போ நம்ம எக்ஸாக்ட்டா root 5 gr கொடுத்தேன்னு வெச்சுக்கோங்க. எக்ஸாக்ட்டா நம்ம and you know the relations we have derived, right? velocity relations அப்படியே இருக்கும். velocity relations அப்படியே இருக்கும். அதுக்கு அப்புறம் we talked about the tension versus velocity relation, right? அதுக்கு பதிலா என்ன வரும், normal reaction with velocity, அந்த ரிலேஷன்ஸ் வரும். இங்க என்ன ஒரு normal reaction related to the velocity. இங்க பாருங்க, at the bottommost point நம்ம இந்த velocity கொடுத்தேன்னு வெச்சுக்கோங்க, exactly root 5 gr. அப்ப என்ன ஆகும், when it is going to the topmost point, அதோட velocity எவ்வளவு வரும், root gr வரும். already based on our previous discussion. இங்க வர root gr வரும். இது எப்படி, u square is equal to v2 square plus 4gr, அந்த ரிலேஷன் பேஸ் பண்ணி. ஓகேவா? சோ இதுதான லிமிட்டிங் கண்டிஷன். அப்ப என்ன, டாப் மோஸ்ட் பாயிண்ட்ல நார்மல் ரியாக்ஷன் இஸ் கோயிங் டு பிகம் 0. அங்க என்னது, we talking about the tension, இங்க என்ன வரும், நார்மல் ரியாக்ஷன். ஓகேவா? so this is the condition about the looping. What is the looping condition? Same, the bottommost point la நம்ம கொடுத்த velocity rate u should be more than or equal to root 5 gr. so அங்க என்னது, we are having the relations between tension and velocity. இங்க என்ன வரும், normal reaction and velocity. இங்க பாருங்க, bottommost point la what will be the normal reaction value, n will be equal to what, mu square by r plus mg. அதனால if you are giving this root 5 gr velocity rate, normal reaction எவ்வளவு வரும் பாருங்க, it will be coming as 6 mg வரும். u க்கு பதிலா நீங்க root 5 gr சப்ஸ்டிட்யூட் பண்ணா normal reaction எவ்வளவு வரும், 6 mg வரும். ஓகேவா? அதுக்கு அப்புறம் normal reaction at the point 1 will be equal to what, m into v1 square by r. normal reaction at the topmost point, n2 is equal to what, m into v2 square by r minus mg. same, நமக்கு அந்த அங்க இருக்கிற ஃபார்முலாஸ்ல என்ன வரும், டென்ஷன் வரும். அதுக்கு பதிலா இங்க நார்மல் ரியாக்ஷன், அவ்வளவுதான் டிஃபரன்ஸ். ஓகேவா? சோ அடுத்து என்ன, சேம் as it is the condition for leaving the circle and சொன்னா what is it, அங்க என்னது, we are using the word slacking ன்னு சொல்லிருப்போம். பட் இங்க slacking ன்னு சொல்ல முடியாது, ஏன்னா slacking is only for the rope, loosening or slacking is for the rope. இங்க என்னன்னா we will use the word leaving the circle, அப்படியே அந்த tangential directionல லீவ் ஆயிடும். அதுக்கு என்ன கண்டிஷன், at that particular point normal reaction should become 0. பட் என்ன, அந்த இடத்துல velocity 0 ஆகாது, வெறும் நார்மல் ரியாக்ஷன் மட்டும் will become 0. ஓகேவா? அங்கேயும் அப்படிதானா, என்னது, for the slacking to happen the tension at the point will become 0, but velocity 0 ஆகாது. அதனால it will be going in a, அப்படியே அந்த tangential pathல போனா it will go in a parabolic path. so அதுக்கு கண்டிஷன் என்ன, velocity of the bottommost point location la velocity should be between root 2 gr ல இருந்து up to root 5 gr. அதுக்கு அடுத்து என்னது, when the velocity you give is less than or equal to root 2 gr, அப்ப என்ன நடக்கும், oscillations. so oscillations ன்னு சொன்னா it will go to a point where the velocity is becoming 0. அதுக்கு அப்புறம் அங்க இருந்து திருப்பி அப்படியே கீழ வரும், it will go in this oscillations. okay, so this is about the particle which is moving in a vertical circular motion inside a smooth spherical shell. This is what, inside a smooth spherical shell. so நமக்கு இங்க ஒரு டவுட் வரலாம், what is it, if you are having say இந்த மாதிரி ஒரு spherical shell இருந்தா வெச்சுக்கோங்க, we are not keeping the object inside, but outside ல ஒரு ஆப்ஜெக்ட் நம்ம பிளேஸ் பண்ண என்ன ஆகும், இங்கல இருந்து நம்ம கொஞ்சம் அப்படியே நம்ம ரிலீஸ் பண்ணா what is going to happen, the object is going to come along this outer surface. the object is going to come along this outer surface. but என்ன தெரியுமா, அது அப்படியே full circular motionல வராது. it is not going to come in the circular motion. it is going to leave the contact with the surface at some point. என்ன நடக்கும், at some point வந்ததுக்கு அப்புறம் let's say in the point வெச்சுக்கோங்க some theta, at some point it will be leaving the contact with the surface and it will go in a path like this. relieving the contact and சொன்னா what is it? Always our condition. So when the surface are in contact is leaving means what? அந்த இடத்துல normal reaction is going to become 0. So நம்ம outer surfaceல place பண்ணி நம்ம release பண்ணா from the topmost point என்ன ஆகும்? It will not be able to complete the end. The outerல இருக்கா. So இங்க என்னது inner, it is inside the shell. அங்க அப்படி கிடையாது, it is outerல நம்ம move பண்ணா what is going to happen? At some point the object is going to lose the contact with that spherical surface and it will fly off. Okay va? So அங்க என்னது, the condition there will be what? At that particular point the normal reaction value is going to become what? 0. So அது base பண்ணி we have a very standard question. It's a very standard question. நீங்க இந்த result நீங்க ஞாபகம் வச்சுக்கலாம். Sometimes these kind of standard questions can be asked as it is. So a small body of mass m slides down from the top of a hemisphere of radius r. எங்கல இருந்து இதுதான் நான் சொன்னது, outside. ஓகேவா? So the top of the surface ல இருந்து it is sliding down. எப்படி? frictionless, friction கிடையாது. The height at which body loses contact with the surface of the sphere. So எங்க இது contact lose ஆகும்? So பாருங்க, let us say it is covering an angle theta ன்னு வெச்சுக்கோங்க. So what is the condition for losing the contact? Normal reaction value should become 0. adana. What is the condition for losing the contact? Normal reaction value should become 0. So inga parunga, topmost point velocity evla 0. Ena we are releasing it. Topmost point velocity evla 0. As it is coming down, adoda gravitational potential energy decrease agum, kinetic energy will be increasing. Inga parunga, if it is coming down, மேல இருந்து it is coming down. Okay, so what is the thing? நீங்க அப்சர்வ் பண்ணுங்க. So இது நம்ம தீட்டான்னு சொன்னா this is the radius, right? Okay, so பாருங்க, this is what? இது எவ்வளவு? What is this? r cos theta. இது என்னது? r cos theta. ஓகேவா? So totally what is the initial height above the reference r? அதானா? above the reference level r. Okay, so initial இத நம்ம ரெஃபரன்ஸ் எடுக்கலாம். Initial potential energy எவ்வளவு? m into g into r. Final potential energy ன்னு சொன்னா இது என்னது? It is at height h, what is equal to r cos theta. So mgr into cos theta. Final potential energy எவ்வளவு? mgr into cos theta. So what is the decrease in potential energy? இங்கேயும் அப்படிதானா? We can use the mechanical energy principle. What is it? Either we'll say initial kinetic energy plus potential energy value is equal to final kinetic energy plus potential. அப்படியே சொல்லலாம். இங்கனது எப்படி? We can say whatever the இங்க என்ன இருக்கா, potential energy is losing, so loss in potential energy is equal to gain in kinetic energy. அப்படியே சொல்லலாம். The mechanical energy conservation statement, right? We can say in two ways. What are the two ways? Either we'll say initial kinetic energy plus potential energy is equal to final kinetic energy plus potential energy. அப்படியே சொல்லலாம். இங்கனது எப்படி? When you look at it, right, let's say potential energy is decreasing. இப்போ இந்த term நாம் left side எடுத்துட்டு வாங்க. P initial minus PE final. What is it? Loss in potential energy is equal to KE final minus K initial. That is what? Gain in kinetic energy. அப்படியே சொல்லலாம். Okay, so decrease in potential energy எவ்வளவு வருது பாருங்க? initial minus final தானா? So mgr into 1 minus cos theta வரும். அது decrease in potential energy. Gain in kinetic energy ன்னு சொன்னா what is it? half m v square. So இந்த இடத்துல let's say the velocity is v ன்னு வெச்சுக்கோங்க. What is the gain? ஏன்னா initial kinetic energy எவ்வளவு? 0. So அப்படியே நம்ம ரெண்டுத்தையும் ஈக்குவேட் பண்ணலாம். So ஈக்குவேட் பண்ணா என்ன வரும்? இந்த ரெண்டு எக்ஸ்பிரஷன்ஸ் ஈக்குவேட் பண்ணா அதுல இருந்து என்ன வரும்? We will be able to get the velocity and the angular relation. ஏன்னா இங்க என்ன தெரியுமா? velocityயோட வேல்யூ நமக்கு தெரியாது, v தெரியாது, angle தெரியாது. Okay, so what is the relation? mgr into 1 minus cos theta is equal to what? half m v square. Okay va? So இங்க என்னது? m cancel ஆயிடும். So 2gr smaller 2gr into 1 minus cos theta is equal to v square. So in the relation நம்ம இங்க வைக்கலாம். What is it? v square is equal to what? 2gr into 1 minus cos theta. இது equation 1 வெச்சுக்கலாம். So this is what the equation we are getting by using the conservation of mechanical energy. ஏன்னா the surface is smooth, so அங்க friction இருக்காது. The object is moving along the contact surface. அதனால work done by normal reaction is what? 0. When the object is moving along the contact surface, work done by the normal reaction எவ்வளவு? 0. ஓகேவா? so இப்போ பாருங்க, so we are getting one relation in terms of what? In terms of the conservation of mechanical energy. இப்போ என்ன தெரியுமா பாருங்க, so weight எப்படி ஆக்ட் ஆகும்? it will be downwards. weight will be acting downwards தானா? so இங்க பாருங்க, இது என்னது? we are marking this angle as theta. this is theta we are taking, right? இப்போ இது நம்ம theta ன்னு சொன்னா what is it? this angle is going to be theta. எப்படி? vertical lines and transverse alternative interior angles. இப்போ பாருங்க, the component of weight இந்த பக்கம் என்ன வரும்? mg cos theta வரும், இந்த பக்கம் mg sin theta. so பாருங்க, going in a circular path, right? net force towards the center of the circle ன்னு சொன்னா mg cos theta is towards center of the circle, normal reaction is away from center, is equal to what? m into v square by r. so இங்க என்னது? small r. ஓகேவா? because the radius we are taking it as what? small r. ஓகேவா? so இங்க என்ன? this is the condition for losing the contact ன்னு சொன்னா normal reaction value should become 0, right? so அப்படி நீங்க 0 equal பண்ண என்ன ஆகும்? mm cancel பண்ணலாம். so what we are getting here? rg into cos theta is equal to what? v square. ஓகேவா? so பாருங்க, v square equation 1ல என்ன இருக்கா? 2gr into 1 minus cos theta. இங்க என்னது? rg cos theta. அப்படியே நீங்க ரெண்டு v square equate பண்ணுங்க, 2gr minus 2gr cos theta is equal to what? rg cos theta. and this is what? 2gr minus 2gr cos theta. அப்படியே நீங்க இந்த term right side எடுத்துட்டு போங்க, 2gr is equal to 3gr cos theta வரும். so gr cancel பண்ணா 2 by 3 is equal to cos theta. cos theta value எவ்வளவு? 2 by 3. okay, so finally what is it that we are trying to find? the height at which the body loses contact with the surface of the sphere. அவங்களுக்கு கேக்குறது என்ன? h value தானா? what they are asking us? h value. இங்க பாருங்க, the triangle that we constructed, right? so இங்கல இருந்து நமக்கு என்ன வருது? cos theta value வருது. இந்த ரெண்டு ஈக்குவேஷன் நம்ம சால்வ் பண்ணா cos theta ஓட வேல்யூ நமக்கு வந்தது. so இங்க பாருங்க, this is the triangle we created, right? இதான் நம்ம கிரியேட் பண்ண triangle. இங்க பாருங்க, this is theta. so இப்போ இதுல we have already said what is this? hypotenuse r. so this is what? it is the r cos theta. that is our h. so h ஓட வேல்யூ என்ன? r cos theta. cos theta எவ்வளவு? 2 by 3. so r into 2 by 3, that is 2 by 3 r. so அங்க என்ன நடக்கும்? the normal reaction is going to become 0. so the object is going to lose the contact. அங்கல இருந்து it'll அப்படியே fly off ஆயிடும். so it's like what? இந்த ரீச் பண்ணதுக்கு அப்புறம் it'll have a velocity along the tangential path. it will go out of the circle and அங்க என்ன தெரியுமா? once it is leaving the circle, it will be under the influence of gravity. once it is leaving the circle, it is like what? the particle which is just having an acceleration due to gravity. initial velocity will be at an angle, but its acceleration will be downwards. அது பேஸ் பண்ணி its motion will be decided. ஓகேவா? so what is this? this is about the particle which is moving on the outer surface. it's about the particle moving on the outer surface. ஓகேவா? so இதுல ஒரு standard question. so but இங்க என்ன தெரியுமா? we are not going to do the complete analysis of it. ஏன்னா நமக்கு the vertical circular motion of an object tied to a rope, that's the most important one in terms of the NEET level of questions. and even if you look at the motion of a particle inside a spherical shell, அதையும் as it is தான். but ஒரே ஒரு டிஃபரன்ஸ் என்ன? டென்ஷனுக்கு பதிலா நார்மல் ரியாக்ஷன் வரும், அவ்வளவுதான் டிஃபரன்ஸ். so இது தனியா செப்பரேட் கேஸ். when you're trying to move an object on the outer surface, எங்க கண்டிப்பா அந்த vertical circular motion complete circle கான்செப்டே வராது. ஏன்னா once it reaches some point, right, it will lose the contact and it will fly off. நீங்க ட்ரை பண்ணி பார்க்கலாம். if you are having a dome shape vessel இருக்குன்னு வச்சுக்கோங்க, நீங்க அந்த வெசல் மேல ஒரு ஆப்ஜெக்ட் வச்சுட்டு you just try to push it, அப்ப என்ன ஆகும்? it will come to some distance on that surface, அதுக்கப்புறம் it will leave the contact with the surface. அதுதான் நடக்கும். so எங்க அந்த கான்டாக்ட் லீவ் ஆகும்? if you take the ideal case என்ன? friction கிடையாது. அந்த மாதிரி ஐடியல் கேஸ் நம்ம எடுத்தா what is going to happen? at a height which is equal to what exactly? 2 by 3 r. so from the base ல இருந்து at a height which is equal to 2 by 3 r என்ன நடக்கும்? the object will be losing the contact. So இது நமக்கு எப்படி வருது? We have used two conditions. என்னன்னா, first point is conservation of mechanical energy. அந்த topmost point ல இருந்து ஸ்டார்ட் ஆகுறது. So we are taking the kinetic energy எவ்வளோ 0 there. So அங்கிருந்து கீழே வரும்போது it will be losing the potential energy. So we applied the result, loss of potential energy is equal to gain of kinetic energy. ஏன்னா conservation of mechanical energy principle we can use in two ways. எப்படி? We can say the initial kinetic energy plus potential energy value is equal to final kinetic energy plus potential energy. அப்படி சொல்லலாம். இன்னொரு விதம் எப்படி? If there is a loss in potential energy, that will be resulting in the gain in kinetic energy. So loss in potential energy is equal to gain in kinetic energy. அந்த relation நம்ம யூஸ் பண்ணா we'll get first equation. அதான் நம்ம அங்க மேல எழுதுறது. What is it? V square is equal to 2gr into 1 minus cos theta வரும். அடுத்தது we have used the condition for the normal reaction to become 0. ஏன்னா losing the contact ன்னு சொன்னா the normal reaction should become 0. Second equation வந்தது. அந்த ரெண்டு equations based பண்ணி we are able to get the cos theta value 2/3. அது வெச்சு we are able to find the height where it is losing the contact with the surface. ஓகேவா? இந்த ரிசல்ட் நீங்க ஞாபகம் வச்சுக்கோங்க. This is a very standard question. Okay. So this is what we have to study about the vertical circular motion. ஓகேவா? So next session enna we will be starting with the discussion on some things about the power and engines. Okay, adu mudichittu we will get into the momentum principles. Okay va? So we will see in the next class.